Alright, in this particular video, we're still in Chapter 6, Section 5, dealing with basically not just amplitude and period, we're also dealing with phase shift and vertical shifts. We just talked about vertical shifts. Now we're going to be specifically dealing with this concept called phase shift. So what I want you to do before you call 3, go to your graphic calculator. Alright, I want you to get y equals, alright, I'm going to clear this out, I just want you guys to type in the sine of x, just like that, the sine of x. Okay? Go to your window though, we're gonna change the window settings right here. Instead of it being a y minimum of -5, change it to a -2. Change that to a +2. So when you hit graph, this is what you see. Now this is y equals the sine of x. Where did we start out at? We start out right here at a -2 pi, goes all the way out here to +2 pi. What's the period of y equals the sine of x? Yeah, it's 2 pi. Basically, it goes what? It starts here, goes down, and it finishes right there. That's one period of 2 pi. From 0 pi to 2 pi. Now, a phase shift is where it slides left or right. So check this out. Y equals, I want you to go down, and I want you to type in sine of x, and I want you to do minus pi. Okay? Sine of x minus pi. I want you to hit right. Now, kind of cool, huh? Now let's think about what happened here. Alright? Where did I start normally? I started here, right? And your normal period, right, went from here down and back up. We had a phase shift. What did I put in? I put a minus pi, correct? So, normally our graph was y equals the sine of x, but the red graph was what? Y equals the sine of x minus pi. So right now, look at your standard equation, right? Y equals a sine open parentheses b theta minus c plus d. You guys see that in your journal? You guys have probably written that down in your journal. What's our a value for the sine of x? What's our a value? Just a 1. Our b value is also a 1. What's the c value for the sine of x graph? The c value was 0, and the d value was also 0. But for the red graph, the a is still 1, the b is still 1. But what's our c value? Yeah, our c value is pi. Because if I plug in, right here, I plug in what? What did we plug in instead? We plugged in a pi. What's the d value? What's the midline? It's still at y equals 0. So basically, there is a formula for phase shift. Here's your phase shift formula. Phase shift. In this equation, right here, your phase shift is your c value over your b value. Well, what was our c value? Pi. What was our b value? 1. So in this particular case, we had a phase shift equal to what? What was our phase shift equal to? Pi. Now this might make sense if I do something right here. We've moved over pi units. Well, right here, we normally started here. Look where your graph of your sine function now shifted over. What's the distance from here to right there? That distance is pi units. So it shifted over, and now I want you to think about where it starts. Instead of starting here at 0, where did we shift over? We shifted over pi units, and now that's where it would start. It would finish right there. So I'm going to highlight it right here. Our first one goes from here down and back over. What happened? Yeah, it translated what? Pi units over. That's what a phase shift is when you shift it left or right. Okay, when you shift it left or right, that's what happens. So what we're going to do now, okay, I'm going to hit y equals. I'm going to go ahead and clear these out. Let's go ahead and put in our problem. All right, so let's look at our problem. Our problem is 2 sine theta plus pi over 2 minus 3. So we're going to type that in. We're going to go 2 sine theta is just x. Is it plus or minus? Plus, ooh, this one's a plus pi divided by 2. Close parentheses, minus 3. Okay, so from our previous one, what is the vertical, not the phase shift, what's the vertical shift of this one? -3, right? So our midline is going to be -3. Okay? We might need to change. Right here, I want to see where it says 4 and -4. Actually, I want you to go all the way up to a 5 and a -5. So go to your window. We're going to change this from -2 to a -5. Maximum, I want you to put +5. Okay? Then I want you to hit graph. Take a look at it. Alright? There's your graph right there. What we're going to do is we're going to take a screenshot of this. Okay? And I'm going to, first thing I'm going to do is I'm going to label all of my zeros right now. I'm going to label all of my zeros. Okay? So right here, this is pi over 2. I'm at pi right here. This is 3 pi over 2. This is 2 pi. Just labeling all of my units right here. So I'm going to leave that up there for you guys to kind of jot down on your paper, and then we'll look at all the different things for this particular function. So y equals 2 sine theta plus pi over 2 minus 3. I'm going to write down what my a value is. I'm going to write down what my b value is. C and D. All right, so there's your standard form right there. All right, what's our a value for this one? 2. All right. So remember, what is amplitude, everybody? Amplitude is equal to the absolute value of a. So yes, our amplitude is going to be 2 in this particular problem. All right, so our amplitude is 2. What's our b value? 1. Correct. This is where it gets tricky. This says minus c. Can everybody see right here that says a b theta minus c? But I have a plus pi over 2. So our c value is not going to be plus pi over 2. It's going to be negative pi over 2. Because if I were to take this right here, if I were to take this and grab it, ready? And put it right in there for c, I have a negative and another negative. And what's a negative times a negative? Positive. So if you have to take this and plug it in, that's going to make this a plus pi over 2. And what's your d value? -3. Now, what we're going to do right now is we're going to take this information. You're going to go back to your page. Where is it? Right here. Our amplitude is 2. Our vertical shift was a -3. What do we have to find? We have to find our period. Okay? By the way, your period, everybody, is going to be 2 pi over whatever your value for b is. What's our b value in this particular case? It's a 1. So our period is going to be 2 pi over 1, which is just a 2 pi. So our period just stays 2 pi. All right? The phase shift, though, is going to be the c value over the b value. What was our c value in this particular case? It was negative pi over 2 divided by, our b value is a 1. So our phase shift, everybody, is a negative pi over 2. That's your phase shift for this problem. We're going to find our graph. Where is it? we go. Let's put amplitude was 2. Our period was equal to 2 pi. What did we figure our phase shift was equal to? Negative pi over 2. And our vertical shift? Okay? So right now, those are all the answers. I want you guys to take this information right here and let's put it on our graph. Where are we going to start at? We're going to start right here at a -1. You're going to go down right here and you're going to bottom out right here at a -5. So I'm going to help you guys with your graph. So what I want you to do is I want you to draw your midline first. So on your paper, draw your midline. Right here. There's your midline. Then I want you to go up how many units? Go up 2 units with your ruler. Go down 2 units. Basically at the bottom of that arrow, that's where that -5 would be. And we're going to plot all of our zeros first. Where were all of our zeros located? Yeah, the pi over 2 right here. Okay? So I'm going to put that pi over 2. So right here, this is at pi over 2. My zeros are right here. Right here. At negative pi over 2, which is right here. And at negative 3 pi over 2. That's where all our zeros are. Then we're going to start at negative 2 pi. We're going to start right here at negative 2 pi and -1. Negative 2 pi and -1. I'm going to put a point right there. And it's going to bottom out where? It's going to bottom out right here at a negative pi, at a -5. So as I draw my graph, I'm doing green. It's going to go down through the 0. It's going to bottom out and go back up. Where's it going to? Well, at 0, right? At 0, it's going to reach a -1. It's going to turn, go right back through pi over 2, bottom out at pi, and then finish where? Finish all the way up at 2 pi. All right? So as you're drawing it, what do I want you to do? Put your zeros first, right? Always plot your zeros first, then figure out where do you start and start working through your sine or cosine function. So the last thing we're going to do is we're going to show you the phase shift in the graphing calculator. So there's my graph, okay? I'm going to hit y equals, and I'm going to go down here and I'm going to basically do the exact same graph in this purple color right here, except I'm going to take away the pi over 2. So you see what it would look like without it. So I'm going to hit 2 sine x, close parentheses, -3. So I'm going to do the exact same thing, just taking away this what? Pi over 2 right there. I'm going to hit graph. Now, this right here, if you look at this graph starts here and finishes right here. So I'm going to go through a full cycle. It would start basically at 0, -3. It goes through a full cycle right there. There's 2 pi. That period was what? 2 pi. But right now, look, where do I start on this one? You shifted over how far? Look at the blue. What does it shift over? It started here and it shifted over how far? Negative pi over 2. That's the distance. Oh, the board's reset. Great. That's the distance from here to right there is negative pi over 2. What was our phase shift? Negative pi over 2.